Section 2.4, Average Rate of Change. We got into this a little bit in Section 2.1 when we talked about the difference quotient. Average rate of change is really just the slope of a line between 2 points on a function that doesn't have a constant rate of change. So you can see here this function I've drawn doesn't have a constant rate of change. Here it's decreasing. Now it starts to increase. Now it flattens out and starts to decrease again. So you can see that the rate of change is different depending on where you are in the function. So linear functions have a constant rate of change. These types of functions, we can calculate an average rate of change by choosing 2 points. So I have a point A and a point B, and drawn a line between the 2 points. Remember, a line between 2 points on a function is called the secant line. And the slope of that secant line is the difference in the y values. So that's f of b minus f of a divided by the difference in x values, which is b minus a. And that's just a slope formula. So the average rate of change formula is f of b minus f of a over b minus a. So you're going to just be calculating the average rate of change using a variety of representations of a function. You could be doing it using the graph of a function. We'll calculate it using the equation of a function, and we'll calculate it using a table of values of a function. So as an example here, we have a function f of x equals x minus 4 squared. It's a parabola. It has a changing rate of change depending on where you are. For example, this part of the function is decreasing. So if I drew a line between those 2 points, it would have a negative rate of change, average rate of change. If I drew a line over here between these 2 points, now that would have a positive rate of change. It's on an increasing part of the function. So average rate of change will change on a function depending on which 2 points you choose. So for the first one, part A, between x equals 2 and x equals 3. So here's x equals 2, here's x equals 3. If we drew a secant line between those 2 points, x equals 2, x equals 3, that would be the line we're talking about. So we need to just calculate the slope of that line. So we have some coordinate points here. This is the point 3, 1, and this is the point 2, 4. And if we have 2 points on a graph, it's pretty easy to calculate the slope between those 2 points. The difference in y values is 1 minus 4, and the difference in x values is 3 minus 2. So we have negative 3 over 1, which is negative 3. Negative 3 represents the slope of that line. It's the average rate of change between x equals 2 and x equals 3 on that graph. And it does make sense that it's negative, because if you look at the line, that line has a negative slope. Now for part B, between x equals 4 and x equals 6. So that would be x equals 4 and x equals 6. That's that line right there. So we need to calculate the slope of that secant line between x equals 4 and x equals 6. So we have a point here of 4, 0, and then a point here of 6, 4. So the slope of that secant line is going to be the difference in y values, 4 minus 0, divided by the difference in x values, 6 minus 4, 4 divided by 2 equals 2. So the slope of that secant line is 2. The average rate of change between x equals 4 and x equals 6 is 2. Now, let's try to find the average rate of change using just an equation, no graph. So we have a function 1 minus 3x squared. I'm going to find the average rate of change between x equals negative 2 and x equals 0. We're still going to use the average rate of change formula, which is just the slope formula. And so we have two values for x equals negative 2 and x equals 0, so we just need to have two values for y. So I'm going to call one of these x1 and the other one I call x2. And so what we need to find is f of x1 and then f, let's actually use, here we go, let's use f of x2. Okay, so when we plug in and evaluate negative 2, this is going to be 1 minus 3 times negative 2 squared. Negative 2 squared is 4, so this is 1 minus 3 times 4, which is 12, it's negative 11. Now when we evaluate f of x2, this is going to be 1 minus 3 times 0 squared, which is 1. So the slope formula is just going to be the difference in our y values divided by the difference in our x values. So average rate of change is going to be 1 minus negative 11. That's the difference in our y values. Excuse me. And then we have the difference in our x values. 0 minus negative 2. So we have 12 divided by 2, which is 6. Let's use the same function, excuse me, same function, 1 minus 3x squared, calculated again, but between a different span of x values. So now we have x equals 2 and x equals 2 plus h. So again, I'm going to call that one x1, I'm going to call that one x2, and find f of x1. That's going to be 1 minus 3 times 2 squared. So that's 1 minus 12 again, which is negative 11. Now, f of x2 is 1 minus 3, and now our input is the expression 2 plus h, and that's going to be squared. So 1 minus 3, 2 plus h times 2 plus h, like that, is, if we do the distributive property here and distribute all of that, we're going to have 4 plus 4h plus h squared, and that would be 1 minus 12 minus 12h minus 3h squared. And that would be let's see, we would have negative 3h squared minus 12h minus 11. And so now when we do the average rate of change, it's the difference in the y values. So we have a y value here and a y value here. So we need to find the difference. This would be negative 3h squared minus 12h minus 11. So there's f of x2. Now we subtract f of x1. And then the difference in x values. Since I did f of x2 minus f of x1, I've got to do x2 minus x1. You got to keep things in the same order. So x2 is going to be 2 plus h, and then I've got to subtract x1, which is 2. So those are going to cancel. Those are going to cancel. We have negative 3 h squared minus 12h all over h. And this, if we factor in the numerator a negative, let's factor out an h rather. So, well, we could do a negative 3. Negative 3h, then that's going to leave us with h plus 4 all over h. Cancel that out. We have negative 3h plus 4 as our average rate of change. Now, one thing I meant to mention earlier on, I apologize. There is a phrase that your homework is going to ask you about in some of your homework problems called net change. So going back up here, the average rate of change is this entire formula that we've been using. The net change is just the numerator. So if we took just the numerator, that's called net change. So when they ask you to find the average rate of change and the net change would just be the value you get in the numerator before you divide the denominator. So for example, here on part A, net change would be negative 3. On part B, net change would be 4. The problem that we just did, for example, here, this expression here in the numerator would be your net change, and then once we divided, that would be the average rate of change. Just something to be aware of. Okay, there are a couple of word problems or application problems that we're going to look at in your homework. So I have an example here. We have a table of values that gives temperatures on an hourly basis, and it wants us to find the average rate of change between 8 and 9, between 1 and 3, and between 4 and 7. Finding average rate of change on using a table of values is actually very, very quick and easy because we have the y values and we have the x values that we need. So between 8 and 9 right here, we have a difference in y values, and then we have difference in x values. So table of values is pretty easy. So for part A, between 8 and 9 a.m., it's going to be the difference in y values, so 40 minus 38, divided by the difference in x values, so 9 a.m. minus 8 a.m. So we get 2 over 1, which is 2. Now, the average, it's called an average rate of change for a reason. We need to have unit values. Rate, if you think about like a car traveling, rate is miles per hour, or if someone's walking, it's feet per second. And so if this is a rate that's representing an actual quantity, we need to have unit measures on there. So the numerator was degrees, 48 degrees, 38 degrees, and then the denominator was in terms of hours. So our rate is 2 degrees per hour. The average rate of change is 2 degrees per hour. For part B, 1 p.m. to 3 p.m., we have 1 p.m. and then to 3 p.m. there. So again, we have a table of values that gives us our y values and our x values. So the change in y values would be 67 degrees minus 62 degrees. And then the difference in x values turns out to be 2 hours again. So we could do 3 minus 1. It gets a little confusing when we're mixing AM and PM. And so I'm just going to go to military time or 24-hour time. So 3 p.m. is 1500 hours. So I'm just going to say that's 15. And then 1 p.m. is 1200 hours, 1300 hours rather. So minus 13. And then we get 5 over 2, which is 2.5 degrees per hour. So the average rate of change is a little bit higher between 1 and 3, and it's still increasing. So the temperature, and it's interesting to note, between 8 and 9, it's increasing at a rate of 2 degrees per hour. So it's getting warmer. And same with part B, it's increasing at a rate of 2.5 degrees per hour. It's still getting warmer. We would expect that because it's still a little bit earlier in the day. But if we go between 4 and 7, let's try to think about this before we calculate it. Between 4 o'clock and 7 o'clock, what do we expect the temperatures to be doing? Rising or falling? And obviously they're going to be falling because it's getting evening time, and so we would expect to have a negative average rate of change. For part C, we have 7 p.m. The temperature is 51 degrees. But then at 4 p.m., the temperature was 64 degrees. So 9 p.m. is 1900 hours, and then 4 p.m. is 1600 hours. So 51, or 64 rather, minus 51, it's negative 13 divided by 3, which is negative 4.3 degrees per hour. So negative average rate of change just means that temperatures are falling. And that ought to do it. Section 2.4 was quick. So just as a review, we calculated the average rate of change, and we also talked briefly about the net change. Net change is just the difference in the values of the numerator. But we calculated average rate of change, like this one, for example, was based on a table of values. Here we calculated average rate of change when given an equation. And here we calculated average rate of change using the graph and just finding points on the graph and using those XY values.